Hello, everybody. So we did exponential and exponential growth and decay yesterday, and those were exponential functions. Well, now we're getting into the heart and the meat of exponential functions, and that's to be able to solve exponential equations. All right. So, for instance, okay, so this one problem here, 3 to what power gives you 81? All right, well, that's a nice integer number. 3 squared is 9, 3 to the third is 27, 3 to the fourth is 81. So this would be 81. That's easy, all right? X would equal 81 because 3 to the fourth is 81. All right, well, now how about this one? 3 to the x equals 18. Well, again, we know that 3 squared is equal to 9, and I know that 3 to the third equals 27. Well, I want 3 to what power gives me 18. So I know that it's going to be between 2 and 3, but I don't know exactly what. And it's not too difficult to figure out what it would possibly be. Again, we could approximate it, fine. It would be like 2 point, it's almost halfway. I bet it's like 2.4, 2.5, somewhere in there. You could use your calculator if you want, not a big deal. Okay, I'm just getting to the point of where we need what's called a logarithm in order to be able to solve this. Okay, so actually 3 point, oh, it's going to be higher than that. So 3 point, so 3 to the 2.6. Yeah, that's a bit better. To the about 2.6. But again, it's approximation. Okay, so here's the issue. That's not too bad. But what if you get into really difficult things? Like I wanted to do like 27 to the 3x minus 25 equals 4,821. I really do not want to spend a bunch of time trying to guess and check my way through this. So there is this item called a logarithm. And a logarithm is what is going to allow you to solve for an unknown exponent. All right. So this is a brand new term for us, logarithm. Forgot the H. So to find an unknown exponent, one must use a logarithm. Okay, so here's the way that logarithms are designed. Logarithms and exponents are completely universal, or are completely equal to each other, I guess I should say. Okay, one form is the same thing as the other form. We're going to be converting from logarithmic to exponential form. All right, so we're going to let let b and y be positive numbers with b cannot equal 1. The logarithm of base b denoted by, hey, there's my dog again. All right. Oh, the UPS man's here. Hold on a second. I got to get a packet. And I'm back. It was some cleaner for our siding outdoors. Ooh, real exciting stuff, guys. Anywho, okay, the logarithm of y with base b is denoted by log subscript b of y. It's also defined as saying, okay, so here is how you're going to go from exponential to logarithmic form. Okay, so log base b of y equals x if and only if b to the x equals y. Okay, this is the logarithmic form of this exponential form. Okay, so they equal each other. All righty. Now, the way that I've been reading this, so you have it written down, the expression log base b of y is read as that. I would say log base b of y. That's how you read those. Okay. The thing to remember is logarithms always equal the exponent. Okay, so when I go back up to here, when I'm trying to find an exponent, if I convert this to logarithmic form, the logarithm equals an exponent. We're going to talk about how to calculate a logarithm. That way you can calculate what that exponent is. Okay, so here are We got 1, 2, 3, 4, 5, 6 examples of something that's in a logarithmic form. We're going to convert that to exponential form. So remember, logarithms always equal the exponent. Logarithms always equal the exponent. So guess what? All of these in the yellow are exponents. Okay, so exponent, exponent, exponent. Logarithms always equal the exponent. Now when I read it, I say log base 2 of 32 equals 5. The base, when I'm looking at an exponential form, b to the x equals y. This b is the base, this is the exponent, and then this is just a value. So when I'm saying base, log base 2 of 32, the base of the logarithm is always the base of the exponent as well. Okay, so 2, 7, 13, a half, 8, x. Those are all bases. So this becomes 2 to the 5th power equals 32. So the value, the 32, the 1, the 13, the 2, the 2, the 25, that's what the exponent is equal to. So the green is all the bases, the blue is all what it's equal to, and the yellow is all the exponents. That's all it is. It's just a conversion. So I have 7 to the 0 equals 1, which is true. 2 to the 5th is 32, 7 to the 0 is 1. 13 to the 1st is 13. That's true. 13 to the 1st is 13. 1/2 to the -1 equals 2. That is true, because what happens when you take a negative exponent? These flip places. So when I take this to a negative, it gives me 2. 8 to the x equals 2. And lastly, x squared equals 25. All right, so let me go back and color code these again. So all of these numbers matched the yellow on the left side. These bases all match the green on the left side. And lastly, these values all match the blue. Okay, so that's how you convert from exponential to logarithmic. Okay, so you guys are going to try 3 of them right now. Boom, boom, boom. You're going to do 3 in a row. Okay, before we move on to exponential, converting to exponential form. So you're converting these to the exponential form. So what is this as an exponent, exponent, exponent? And go. All right, now converting from exponential back to logarithmic. What was the rule again? Logarithms always equal the exponent. So when I'm setting this up as a logarithm, the log base something of something should equal the exponent. Okay, so right now on all of these, I know that I'm going to have a logarithm. I'm going to have a base number. I'm going to have a value number, and I'm going to have an exponent. The logarithm always equals the exponent. So log base something of something equals the exponent. 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 Okay, logarithms always equal the exponent. All right, now the little number, that's the base. Log base something. Well, what's the base? The base is the base of the exponent. So the little subscripts, these little tiny numbers down here, that is the base of the exponent. So it's log base 2, log base 8, log base 5, log base a half, log base 6. And then we just have to fill in that last number. Okay, so that last number is this value here. Okay, so the value 32, that's the big number always. 32 is the big number. Okay, so log base 2 of 32. Log base 8 of negative, whoops, messed that one up. Log base 2 of 1/64, or excuse me, log base 8 of 1/64. Log base 5 of 1. Log base 1/2 of 32. Log base 6 of 36. So let's color code those again. Green, bases. Light blue, values. Yeller, exponents. Logarithms always equal the exponent. All right, now it's your turn. You're just converting it to a logarithm. Just converting it to a logarithm. Ready, set, go. All right. So, what is the purpose again of a logarithm? So that we're able to solve for unknown exponents. Okay, so we'll get into that more tomorrow. Not tomorrow, maybe the next day. Okay, so this purpose is, say for instance, we were trying to find this value right here. 3 to what power gives us 27? Okay, well, if you didn't know it off the top of your head and you weren't able to figure it out, this one, I'm giving you some easy ones. This is how a logarithm would be used. You would be converting this into a logarithm. Log base 3 of 27 is equal to the exponent. The exponent's unknown. So this is what you're asking yourself. That's literally the question. 3 to what power is 27? That's what this means. 3 to what power gives me 27? 3 to what power is 27? And hopefully we know that that is 3. All right. So when you're asked to evaluate a logarithm, that's what you're looking at. You're asking yourself a little question. 3 to what power gives you 27? All right, what's this question asking? 49 to what power is 7? So 49 to what power is 7? How do we get from 49 to 7? Think about that. You have to go from a 49 to a 7. How do those relate? Hopefully you're thinking in your head, well, to get from 49 to a 7, I would have to take the square root of that. What is the square root as a radical? See, this is why we did this last chapter. Or, excuse me, what is the square root as an exponent? And hopefully you would recognize that as an exponent, that's a half. So 49 to the 1/2 power is 7. That's the answer. That's what log base 49 of 7 is. It's 1/2. That's what it'd be equal to. Okay, so you have 2 more problems for today. Just tell me what these are equal to. What does that equal? What's that equal? And then move along your merry way. Alrighty. Talk to you guys tomorrow, guys. See you later.